Welcome to Fascinating Frontiers, episode 130, coming to you on July 13th, 2026. New week, new discoveries. Let's see what's happening. A Chinese probe has reached a quasi-moon while JWST reveals a hot Jupiter with violently different day and night sides. JWST captured simultaneous views of a tidally locked hot Jupiter's day side and night side during a single transit event. Strong winds appear to strip water molecules apart on the hotter face, while the cooler side remains comparatively calm. The observations highlight gaps in current atmospheric models that do not fully account for such sharp gradients. Data were collected using multiple instruments, and follow-up programs will target similar worlds to test the findings. Remember, the show covered JWST exoplanet work in episode 127, and these new hemisphere contrasts directly address open questions on biosignature detection prospects. Now, on a completely different note, astronomers using JWST observed a tidally locked hot Jupiter showing two dramatically different faces at once. The day side appears battered by fierce winds that break apart water molecules, while the night side remains calmer. The data expose shortcomings in current atmospheric models that fail to predict such sharp contrasts. Follow-up observations of similar planets will test whether this pattern is common or exceptional. These results extend the JWST exoplanet program by supplying direct evidence of violent chemistry that earlier models overlooked. If Earth were locked so one side always faced the sun, the day side would roast at temperatures hot enough to melt lead, while the night side plunged below freezing. On a hot Jupiter orbiting its star in just a few days, that contrast becomes extreme enough to drive planet-wide winds faster than any hurricane on Earth. The permanent day side can exceed 2,000 degrees Celsius, while the night side stays hundreds of degrees cooler, forcing a powerful circulation cell that carries heat across the terminator. JWST has now measured these winds indirectly by watching how different molecules appear or vanish between the two hemispheres during a single transit. The mechanism is simple in principle, yet produces chemistry that current models still cannot fully reproduce, especially the apparent destruction of water on the hot side. The open question is whether these same winds also mix heavier elements upward from deeper layers or whether the atmosphere remains stratified despite the violent flow. No one yet knows how the vertical mixing scales with wind speed across the full range of observed hot Jupiters. New missions and instruments keep revealing how little we still know about the environments beyond our solar system. China's Tianwen-2 probe has arrived at Earth's quasi-satellite 469219 Kamaoleva following its rendezvous. Mission controllers are now assessing the asteroid's composition and rotation state using onboard remote sensing instruments. The spacecraft carries hardware for both remote sensing and potential sample collection. Data returns so far confirm the target's stable orbit relative to Earth. Further maneuvers will refine the observation campaign before any contact or sampling attempt. From extreme exoplanet atmospheres to our own solar system's small body exploration, where another spacecraft has just arrived at a near-Earth asteroid. Astronaut Shubhanshu Shukla described plans that include an Indian space station and crewed lunar missions as part of the next decade's roadmap. The program builds on current robotic lunar efforts and the ongoing Gaganyaan human spaceflight project. Engineers are developing life support systems and docking technologies required for long-duration flights and station assembly. International partnerships are being explored to accelerate capability development in propulsion and habitat modules. The first crewed flight remains targeted within the coming years. While China advances its asteroid mission, India is laying out a broader human spaceflight roadmap for the coming decade. King Charles III visited the UK's largest space cluster on 10 July to launch the new initiative designed to shape the future of the space and defense economy. The gateway strengthens ties between the UK and ESA across civil space programs and defense applications. It builds directly on existing UK facilities that already support multiple ESA missions in satellite technology and launch services. Officials expect the center to coordinate future joint projects, including shared infrastructure for workforce development and technology transfer. Formal agreements on operational scope and funding contributions are the next milestones. As national agencies expand their ambitions, Europe is investing in new ground infrastructure to support both civil and defense space activities. The European Space Agency will establish a dedicated facility in the Polish capital focused on research, technology development, and industry partnerships. This marks an expansion of ESA's physical presence into Central Europe beyond its current member state sites. Local authorities are preparing sites and support structures to host the new operations. Construction timelines and the initial program focus areas, such as satellite systems and data services, remain under discussion between ESA and Polish partners. The UK Gateway is the latest in ESA's growing physical footprint. A new center is now planned for Central Europe. The company received regulatory clearance to fly its initial light-directing satellite later this year. The test craft will demonstrate controlled reflection of sunlight toward specific ground locations. Plans call for thousands of additional mirrors over the next decade if the technology proves viable. Engineers must still address orbital debris and brightness concerns raised during the review process. The first launch window opens in the coming months. While agencies build new facilities on the ground, a commercial startup has just cleared regulatory hurdles for an orbital mirror demonstration. Helio has completed vibration testing of its deployable antenna system under a NASA Phase 2 SBIR contract. The hardware targets small satellites that must survive intense launch conditions. Performance measurements were taken across several frequency ranges during the trials. The successful campaign advances the design toward an eventual orbital demonstration. Subsequent phases will examine thermal behavior and full deployment sequences ahead of flight. China has designated the Long March 10C variant as its primary commercial launch vehicle after the first booster recovery. The rocket employs liquid methane and liquid oxygen engines to support rapid reuse. Additional funding has been directed towards several commercial rocket developers working in parallel with the state effort. Recovery procedures will be refined across the next series of flights. The vehicle is positioned to handle both government and private sector payloads in the commercial market. A NASA CubeSat is preparing to test new components once it reaches low Earth orbit. The platform was chosen to keep development costs low and timelines short. Onboard instruments will gather data on propulsion, communications, and sensor performance. Launch is set for a rideshare slot scheduled later this year. The results are expected to guide designs for later operational missions. The young open cluster M29 sits just under 8 degrees south of Gamma Cygni and is already prominent after sunset. Binoculars or small telescopes can reveal it even under moderate light pollution. Several bright blue stars stand out against the surrounding Milky Way field. Its distance and age provide a useful reference for studies of recent star formation. Viewing conditions stay favorable through the coming week. From emerging commercial concepts to proven long-duration missions, the Voyager 1 spacecraft continues to send data from the edge of interstellar space. After nearly 49 years, the Voyager 1 spacecraft has reached only 166 AU, roughly 24.8 billion kilometers from Earth. The distance underscores how vast interstellar space remains, even at record speeds. Both Voyager probes continue to return measurements from the heliopause region. Power levels are declining, but instruments are still operational. Scientists expect data collection to continue into the 2030s. A kilometer-deep instrument in Japan recorded a possible first signal from the cumulative neutrino flux of all past supernovae. Confirmation would provide a new census of stellar deaths across cosmic time. The detector's sensitivity allows it to register events far below the threshold of individual supernova observations. Analysis is ongoing to distinguish the signal from background noise. Additional data runs are planned through the coming year. Most lunar water is thought to exist in chemically bound form within the mantle rather than as ice at the poles. Polar crater deposits represent only a small fraction of the total inventory. Sample analysis and remote sensing both point to an interior source that has not fully outgassed. Future landers may drill or use seismic methods to measure the deeper reservoir. LIGO, Virgo, and Kagra have now cataloged hundreds of mergers, revealing distinct populations. Some events match predictions for isolated binary evolution, while others suggest dynamical formation in dense clusters. The growing sample allows statisticians to separate the two channels for the first time. Continued observations will tighten constraints on progenitor masses and merger rates. Next observing runs aim to double the current event count. The Space Telescope identified quasars at greater distances than any previously recorded. Their existence at such early cosmic times challenges models of how supermassive black holes grew so quickly. Spectra confirm the objects are powered by accretion onto massive central engines. The discoveries add new data points to the timeline of reionization. Additional candidates from the survey are under review. Next time, we'll be watching for confirmation on the supernova neutrino background signal from the Japanese detector. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Unintended Consequences. True stories of good intentions that backfired. Find every show free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com/gallery. Royalty-free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through